I think we've gotten ourselves stuck in this trap of thinking that physics is complicated and hard, and so the theory of everything has to be some complex system. I disagree. I think that as we go deeper, everything should converge and get simpler. We are built from this stuff after all, and complexity has to start somewhere. Take computers, for example. At the bare bones of computation, it's ones and zeros. That's it. Everything is built off that. Complexity expands from simplicity. While I'm at it, I think that our reality boils down to about the same. And this should have honestly been more apparent to us sooner. There is something and nothing, and everything else comes from that. If we cannot relate something to our reality and observe the symmetry of, as above, so below, it's probably wrong. And I've got two things to say here. One is I'm a huge proponent of this as above, so below thing. And the video I watched about a guy saying, hydrogen is the fundamental particle of the universe. He mentioned as above, so below in his thing. And like I said, it was nonsensical, so it didn't really... It didn't make sense when he said it, but he said it in it, and it kind of rubbed me the wrong way, because I'm like, yes, I agree, but only with that sentence right there. Literally everything else made no sense, and it kind of rubbed me the wrong way because he utilized something that I think is a key concept in the wrong way. But I do think that it's very important to kind of keep that in mind, because that's just how things get built. And like I said, it should have been something more apparent to us sooner when we started creating computers and we used something and nothing as our bare bones starting point. I think it should have been apparent right then and there that meant something. And we're making this artificial universe of ones and zeros, and it's all straight lines and stuff where it's all approximations. But the universe that we live in is ones and zeros, but it's curved lines with infinities of points in between these two states. But, so we've kind of created an optimized approximation universe in computers. And like I said, if we're building our own complexity by building computers, right? We're increasing the complexity of the human race and just what the earth is capable as a whole by doing this, right? And where is this complexity coming from? Ones and zeros. And I think that that is right there is a smoking gun that means something. That's, if that's what we're using to build a whole new, basically, reality, this virtual reality, then it makes a lot of sense to kind of take that and look back at what we have already, our physical reality, and apply it. And so, what was this initial thing about? And so, getting back to what I was saying, I don't think that we need to look at this as it's going to be this crazy complex calculation. I'm not saying the math is going to be necessarily easy. It will be complex because the reality is that we are complex. So at the fundamental level, predicting a single particle's movements should be easy. The problem is that there's so many particles, right? There's so many atoms that just make up a single, we'll say in a single meter by a cubic meter, there are so many atoms that the complexity goes through the roof. And so the calculation goes insane, but the bare bones math should be relatively simple. It's just when you have to apply factors on factors on factors, because you like what's going on here affects what's going on over here, which affects what's going on over here. And it's all happening simultaneously. So it's going to be complex to predict it, but at the bare bones, predicting, individual particles should be very easy. Very easy. But I could be wrong about that, and I think I've talked about it before, and that could be on the fact that we're assuming that we've reached the fundamental level, and that's not necessarily the case. And honestly, if we haven't reached the fundamental level yet, I don't know if we ever will. So, maybe we just cut our losses and approximate from as far as we can go now. As of right now, our models are pretty effective at predicting things. So, maybe we don't need to predict better than, a couple decimal points. But, I don't think we need to have this, complexity be a thing. And I think a lot of people like that it's complicated and it's complex and it's difficult, because it's sort of this badge of honor saying, yeah, I'm a physicist, and look at this complex equation that I came up with. Look at this solution that I found. Look at this answer to a question of the universe that I discovered, right? It's this badge of honor, right? We have prizes for this kinds of stuff. And I feel like to come up with such a simple concept and be awarded for it would be almost seen as sort of embarrassing. It's like that's what you thought, and that you got awarded for that. Like, looking back, it'll look like such a dumb thing, because it'll be like, that's what it took, right? And the thing is like, yeah, it doesn't need to be complicated. I think we want it to be complicated because we want to feel like we earned it. I don't think that it's necessary, though. So I don't know. But, yeah. Peace out.